I think we will. We do. You are live. Jemsen, you are live.
I am alive.
Hello.
Good morning, gentlemen.
You are alive and you are live on LinkedIn. Hey, Jemsen, very good morning.
Very good
Good.
afternoon to me.
Yeah, very good afternoon to you. Yeah, great to see you. Great to have you. We thought we put you on the major screen as you traveled or as you are most far away. We are live. This is so great. Wow, I am so happy. And let me also welcome and let's say hello and good morning to my dear colleague Jonas.
Good
Jonas,
morning,
very
guys.
good morning.
Thank you
Yeah,
very much for
to
everyone to join today.
yeah, I think it's great. Guys, have you seen the numbers? Have you guys seen the numbers? Is so many people. We had
Looks really
400
good.
people signing up for our webinar. This is like we always said, is such a big motivation. Um, Jemsen, I think you have people even knocking on your door. They want to they want to join.
Yeah. They
This
try
is
to
this
touch the
is
big star of Jameson.
this is probably the reason. Yeah. No, guys, first of all, our first webinar in 2023, and we start with a course. Jemson will explain what makes a difference to the webinars we had before. But first of all, let me say hello and very good morning from Germany. And it's so great to have this community here together. We have 400 people signing up. I already see some comments. Hello, everyone from Ho Chi Minh City, from Indonesia, from please just leave us a short message and say hello and good morning from wherever you are. I think it is a community. In the meantime, it is a worldwide community. Our dear colleague Antonio Mena from Brazil. I mean, I know I invited many people also from South America. It's very difficult for them to join because it's in
It's middle
Brazil.
of
It
the
should
night,
be
yeah.
somewhere, yeah, in the middle of the night. But yeah, we have a message here from Romania, Miss Vezan. Very good morning and nice to have you here. A message from Thailand, from Milano, Alessandro, from Egypt. So it is really, yeah, it is becoming kind of a worldwide event. Also from Iran, we have people joining us. It is just very great. So leave us your comment and give us your questions. I think this is important today. We want to interact with you. We want to have your questions, and yeah, we want to understand your special requirements for this. Okay. You might have also noticed this is only a 30 minutes course, and everyone who has been joining who has been joining our webinars so far saw that yeah, sometimes it might be tough to make it in these 30 minutes, but we give our very best, right, Jensen? Yeah. Jensen, what is your expectation to this webinar? What was our idea when we've been doing this new series?
Yeah, you know, collectively over the last 2 years, when we run the webinar, there are some questions that come after the show. So after the show, I have collectively bring this question consolidated together. We make this as a course. And I think that it is very important for us to bring out to answers a lot of very interesting questions that I trust that the audience will appreciate.
Right. Yeah, I think that should be, yeah, let's say our requirement, and that should be, yeah, the questions we should be able to answer.
Sorry, guys, little
Okay,
technical
so
issues.
no, that's okay, Jonas. So okay, first of all, let me do the short introduction. Today we will talk about probe sampling for CEMS, basic probe sampling. Jemson, let me take one of my favorites. I mean, you said many great sentences, but this sentence is one of my favorites. You said there's not just the one sample handling system. This is something we have to touch on here in the session today. But I think the message we want to show is what is the requirement, what is the basic requirements for a sample handling system for continuous emission monitoring. We see our role, our vision, our mission to have a sample handling system which is robust, which will be high available, and which can measure at any time. And I think, this is something we really would like to make sure that after this webinar, at least you have an idea and you understand what is the typical things you should consider. Next webinar in 16th of March, in 1 month of time, we talk about plus. That means not the basic requirements, but plus requirements, special industries, even higher dust application, even more challenging demands and requirements for the solution, for the equipment, for the layout. Yeah. But I would say if today you can have the basic knowledge, I'm pretty sure many people joining here are more far experienced than just having a basic knowledge. But together with a plus knowledge, I think you have a very broad, wide understanding of what is the main requirements in probe sampling system. And last but not least, we have the PSG process webinar. That will be 20th of April, and we will talk about, let's put it down, ATEX, ICX application mainly. Many things are similar, but some things, the technical details are different. So this is the outlook of this course here. And please, if you have any questions, we are very happy to answer them. Let me show one of the questions, maybe a common request is calibration via probe. And I think, Jemson, the probe part is your part, but I think, first of all, thank you for this question. I'm pretty sure Jemson can answer this when we touch on his topics there. Okay, short overview of the world team. Jemson is here. Jose is, I'm pretty sure, also here joining, and Antonio from Brazil. So it's an impressive overview. We have Asia, the Middle East, Europe, and America. Well, worldwide presence, and it really shows the many people joining here that it is a worldwide presence. Okay, so Jemson, I think the stage is pretty much yours.
Thank you. Let me take over. Yeah, having a sample probe. This is a very, very first component of the sampling systems. And you know that the sampling probe is up in the stacks. Nobody wants to reach out to the stack for the slightest ignorance. All right. So therefore, it is very important to get it right, when we're choosing the right sample probe. The blind spot of a blind sample probe was that many people thought that it is just a mechanical probe. And there are many sample probes made in other parts of the world, right? Mm-hmm. So I am very, very, in fact, Jörg, that this is only half an hour. Give me 1 hour next time.
I know. We have to, we have to reduce the time here. It was also a comment from the people attending. But Jemson, maybe we've been showing this PNID quite some time. Would you agree that really we try to point out here the very main component, right?
Yeah. In fact, the three main components of the sampling system, right, is starting from the sample probe, right? This is up all the way up there, and we must get it right. right? I mentioned.
True.
And after the probe, it is so critical that after removing the particles, all right, we clean up the particles, and then we have to address the dew point. All right, we want to remain the sample and the representative. We have to heat up the sample, bring above water, bring it above the acid. So by means of a heated sample transport line, right? Then we bring it all the way to the gas cooler. And this is the area whereby in the system integration, a lot of people make a lot of mistakes. All right, so make sure that the entry to the gas cooler, keep it to a maximum of only 20 centimeter, meaning that the heated sample line, which is so hot of 180 degrees, all right, above the SO2 dew point, well, the gas cooler is 3 degrees C. We want a thermodynamic reaction take place in the gas cooler. And that is why many people make mistakes or the long, naked, unheated, Teflon tubing before it goes into the gas cooler. This is one of the mistakes. So making sure that it goes right into the cooler, this remove the water very effectively before it goes to the other accessories, before it reaches to the gas analyzer. So 3 major components.
No, sorry, Jim. Yeah, I always say we see our task in the extraction of the probe, the transportation of the probe, and the conditioning of the probe, right? This is our understanding of the perfect sample gas solution or the perfect sample gas system, right? And I think this is very important for everyone to understand. And a little similar to data systems, we always say if there is a problem in the input, in the primary sampling, this can already result into problems you have to solve later. So really understand, Jensen, I think that is an experience I made from the many travels we've been doing together. I would say the probes which we saw there is also something, like you said, very mechanical, many people think, but this is not the case, right?
No, so much different. Just the material itself is already talked about. 316 Ti. Nobody understand.
It's not just that the probe will last longer and the quality is higher. But that also has other very special effects, right?
Yeah. So the area where the probes that we're emphasizing on is about maintenance. Nobody wants to go up there to change simply a filter. And this is why in the design of the sample probe, the filter element itself, the design, the way we constructed the filter element, the size of the filter element, all right, which is one of the largest available in the market, just for one reason, is to prolong the maintenance interval period as much as only attention needed once after 12 months. This is what we wanted to say, once after 12, only once in a year. Having consideration that the dust particles in the stacks is always lesser than 200 milligram. And most of the time it's only 50 milligram. Yeah.
Maybe that's a good point in our presentation to answer the question which came up earlier before, if we can calibrate through our probe, James.
Yes, this is a question whereby an audience. So there are many times when the other supplier who has the filter element located at the sample tube at the tip, whereby they call it sinter filter, and somebody call it a pre-filter. In this situation, the calibration need to be injected have to go through the very, very first sampling component, which is the filter element. Now, in our case, our filter element is at the probe itself. It's not the sinter filter. Therefore, the calibration gas is injected directly into the sample probe, passing through our filter, before it goes to the rest of the sampling component. All right. On the other hand, there are other sample probe whereby they have the sensor filter at the tip. So in that case, you have to have an additional pipe, all right, to introduce the calibration gas into the sensor filter. That makes a difference.
Yeah, and I think it's very interesting. Two aspects here. The one aspect, Jensen, is, and I think this is something, more or less related also to the region. You say maintenance. In Europe, in maybe Germany, the focus is more on reducing the maintenance cost, and at the same time, there's very high requirements for the availability of the measurement. So big filter element, less maintenance means more uptime, more online time of the measurement, right? I think this is also something important to outline here. And I know that at least in Europe, there's a legal requirement to calibrate the system via the filter element. I think in the past you can take the shortcut, so to say. So you just calibrated the analyzer itself, not so much considering the sample handling system. But we can see there the legal requirements for these systems are growing and the demand is growing. So good thing to answer here. Okay, so Jensen, maybe a little bit something. I mean, we are sharing some secrets here, but a little bit saying about the filter element itself.
Yeah. So the many of these people think that back purge. All right. So the questions about back purging is only a philosophy if we have chosen the wrong filter element. Right. Many a times that people think that once the particles enter into the filter element, once it enter, it is almost impossible to back purge. It is impossible. So if you see, there are two filter elements, all right, on the sectional. There are 0.3 micron, another one is 3 micron. So the secret lies in that the AGT, the filter element, is a multi-layer. It's a multi-layer, which by this multi-layer allows the particles to be filtering from outside to inside, all right? It's from outside to inside, meaning that the particle flows, all right, collectively on the outside, all right? The outside has the finest surface.
Yeah, I think that's a big difference, Jimson, and maybe you can shortly show the filter element in live. Because you displayed, I think, so nice. The basic probe is on the right, and the plus version you have here, right? Yeah.
Yes.
And maybe it's worth to say that the core, the filter element, will be the same, no matter if we talk about the basic version or the plus version. Yeah. And I think that's very good to show the dimension.
Perfect.
Yeah, you can see that it is a multiple layer, which is darker color, and it's whiter outside. The main reason is to prevent the particles from entering into the filter element. Once it enters, there's no way it can come out.
True. Jensen, I think I have to play the timekeeper here again. I think this slide here, and this is also something, Jensen, we wanted to mention. If you want to have the temperature, just drop us an email, just get in touch with us via LinkedIn or any other channels. You'll see when you enter our website, there's a chat program available. So I think it's very easy, and we can give you that overview, because I think this slide here is very interesting for many people. Why is that, Jensen? I mean, that is the Bible, so to say, isn't it?
Yeah. So the whole design over here was that, we always want to address only one issue, is maintenance. Yeah. Because for the whole design of this sample probe is to tell the buyer, all right, having known that the particles in the stack, all right, it is between 50 to 100 milligram. The design of a filter, which is the biggest filter, surface area of 212 centimeters square, we can last as much as more than 2 years before you require the attention to replace the filter element. This is a message. This is a message we want to know.
Okay. Yeah, and if so, but I was kidding a little bit with the Bible. I didn't want to, have the wrong comparison here. But I think this is really the good overview to say, okay, what is your dust concentration, and what is the solution to choose, right? And if you consider this, I would say you're pretty safe, right? You can look in your application and you can find what is the right solution and what is the right options to choose. Very good. Okay, Jonas. Now,
let me take it over from here.
The very challenging part. Jemson, I think that's a picture from you. Yeah, 2 pictures from you, which you shared. I mean, one picture really is something bad, a burning heated sample line. And this is nothing we want to outline too much. But the left picture is an interesting one because I think, we will, Jonas will explain now the 2 concepts, the cut to length and the not cut to length solution for often underestimated the heated sample line.
Yes, thank you very much, guys. Let me take it over from here. We have, in principle, 2 different systems of heated sample lines. For once, you can, of course, get the usual, or as you know it, or as you can see there, we have our flex systems, which you can see here, which is, you also can see, pretty flexible. It has an outer PA12 ring weld jacket, which you see very often in the industry already. It uses for heating up a fixed resistance heating cable, which you can see here, which is also very flexible. This is why it is used in this type of application. And of course, it reaches 180 degrees like all of our PSG Basic products. This type of heating cable has one big disadvantage. You have already told you a little bit on the side a few seconds ago. It is not cut to length. So you have to order a certain length when you're ordering it, and of course a lot of times, or usually often, you don't want to order a too short length, so you has to connect it to another line or something. And this is why a lot of people just ordering like 10, 12, 20 meters more, and this leads to these loops, to these donuts you just saw in the picture before. And this, of course, leads also to a longer to 90 time.
Okay. Sorry, Jonas, to interrupt you. Jemson, would you say that the left line, the lines on the left side, is a little bit the traditional way of doing lines? I think it's very common, at least in Europe. You have a fixed length, so you will order 75.5 meters. Don't you think that the right part with the extruded lines, I mean, all of them can maintain the 180 degrees C. We have to make sure we are higher than the acid dew point. We have to consider the ambient. Would you agree to that statement or not so much?
Yes. In fact, I was personally felt that in Asia, for CEMS application, as far as my territory is concerned, I always, in fact, wanted them to choose the flex, whereas the one extruded, on extruded, it's slightly, the definition is slightly different. We use it on the process line, like gas chromatograph, like a mass spectrometer, to hold the sample, the positive pressure on a certain temperature, whereas the one on the flex is different. Please, I don't want to take over, Jonas. Please,
no. Back to you. But it's just important to understand both lines, extruded and flex, can maintain 180 degrees C, which is safe, so to say, in a CEM system, because you are higher than the acid dew point. And I think that really helps. And Jonas, I think I just wanted to give this overview again. because
thank you.
I
Thank
think
you
I think it's interesting to show what is the advantage of the extruded version of the heated line, and what gives us more, let's say, opportunities.
Exactly. So thank you very much for sharing a little bit of your professional background with us, Jameson. It's very worthy a lot for us just to hear the stories from outside. So only then we can keep on getting or making our products better. But we talked a lot about this little guy here. This one is one of our PSG Basic extruded lines. It is basically, it contains the same elements which you can see here. It has a tube, in this case a PTFE tube, a temperature sensor, and a heating cable. The heating cable in these extruded lines is a little bit different. We use a parallel heating cable, which has the big plus point that you can cut it to length every half a meter. So you can do basically the same which you would do with the flex line, just order like 10 meter more to be safe, but then you cut it to length at the exact point your probe is, which will lead you to a shorter T90 time, and of course also to a lower energy consumption. Overall, to say this line is more energy efficient than the other one, just because it is mechanically made. So it has a dense layer of insulation around it, and then we are putting it in a machine, and the machine will make this little layer of PVC out of here on the outside. So it's a mechanical made product. And another great plus point is, because it's that densely packed, you can just install it like this, just straight to the ground. Whereas you have these ones, you would always have to lay like little sets. Otherwise, the tube would length itself, and you would have a problem.
I think I think that's a very good point, Jonas, and that's a very good explanation. Maybe to cut down really the overview of the advantages, Jonas. I think one of the development and the calculations, testings you guys have done, or you personally have done, is the lesser power consumption. Don't underestimate this item. Even if energy is not James and you in your region are not in the energy crisis, maybe not in the same, let's say, amount or in the same level of energy crisis like we in Europe are, but CO2 and CO2 footprint is the future. So lower power consumption, cut to length technology, I think, is very important and ultra robust. I think really it's important to say, do not underestimate the heated sample line, and choose the right model. I think that's something.
This is usually by a factor of 20 or 30 the highest energy consuming item in your sampling system. It is far more depending, of course, on your length, but you usually have like 60 watts per meter. And you can just by calculating it roughly, you can see how big this consumer is compared to the other two parts. So like you're saying, don't underestimate it.
Okay, yeah, that's true. Okay, guys, is that really? We have 2 minutes left. It's impossible now to touch on a topic like this with the cooler. Jameson, very short. What is important about the cooler? Because it is so crucial. It is such a crucial item for the sample handling system.
Yeah. I think only one point among all the important points is to ensure that it has a very stable dew point output. The output of after cooling, it has to be very stable, all right? Meaning that there is a changes of water, there's a change of flow rate. Your cooler must able to maintain a stable dew point. Otherwise, you will have a very unstable measurement, unstable calibration.
Yeah. So, Jameson, you are saying that out of these 3 items we selected here, the main criteria, there is more, but I mean, we have to focus here. Outlet dew point, washout rate, T90 time. You would say a constant and a low outlet dew point is the most important one. Who else from the audience would go for that? I think it's interesting to see who else thinks that this is the absolutely right statement. I would like to know. Please, guys, just let me know and just tell me. I think that would be good to know. Okay, so now Jonas, I think I will put you on the bigger screen. Because we also wanted to share with a different type of heat exchanger. At the end, the heat exchanger is responsible for the outlet dew point, also responsible for the washout rate. We have different concepts, but we are basic here. And Jonas is showing our basic cooler, our basic model. And I think
Jameson would say, our new kid on the block.
Yeah, the new kid on the block. Yeah, this is good to say. So, Jonas, maybe some words about the basic cooler.
Yes, of course. Like, this is our newest development over here. We are specifically engineered yet to fit all the concerns, all the purposes in a basic handling system, a basic sampling handling system. It has a jet heat exchanger, which you can see here, which you can change without the need of any tools, which has a really low washout rate. It doesn't have this much of options. It's really made for the basic systems. In our next videos, we will also show you our plus lines where you can add some of the options. But this cooler, it's a compressor cooler. You can see the temperature over here. You have temperature contacts which go out there. But basically, what it does is it gets the water out of your probe, out of your sample, and nothing else. But this is what he has to do. So we really
and a very low and a very low and a very stable outlet dew point. And Jemson, this was your it was again very much summarized, but I think the most important point here. Okay, guys, I'm sorry. We already have 2 minutes. We run over already to 2 minutes. But yeah, I think it's very difficult to do that in 30 minutes. Still, let us together answer some of the questions here, because I'm really happy to have that questions here. Jemson, considering very cool, yeah, can you conclude purging? Yeah, back purging in the probe. What is necessary?
Considering inner layer is very cool.
I think that was from the filter element itself. Is back purging always necessary? And I think that's for the probe a very interesting question.
Yeah.
Because please, James.
Yeah. So the answer to this question is that the inside the sample probe, it is very hot. It is not very cool. All right. It is very hot. It is 180 degrees. Again, it's above water and acid dew point. Is it necessary to do a back purging? Now, questions it is if that sample has a H2S, if the sample has a HCl, if a sample has HF, now no back purging required. All right. As for the rest of the standard CEMS, yes, you can go ahead to do the back purging. Yeah. More importantly, I say again that back purge is only a philosophy. It will not work unless the filter element, all right, is a multi-layer. Otherwise, it will not work.
Yeah, I think that's good to say. And maybe coming back to that overview, that helps you. Do you need a back purging? Don't you need a back purging? Contact our team. I mean, that is what we are here for. We share our experience in this field, and I think we can tell you what makes you the less the trouble on this type of systems. 2 more questions I would like to answer is, what about 2 horses in the heated sample line, one being for spare? That is again a super good point, and thank you for asking this. I think most of the systems in the meantime, for spare, for calibration, I would say, Jemson, more and more lines we see come with 2 or even 3 tubes. maybe sometimes all of them are heated. Maybe one is heated, two are not heated. So yeah, Jonas?
Maybe I can say a word to it. We are very flexible
Sure.
in how to put together your tube, as we are making them ourselves. All of our tubes are made here in Germany with us. We can put up to 11 tubes in the middle, which are heated, and then there are even more in the layer of the insulation. So for example, an unheated calibration tube, we also can offer you to put a power cable inside. If you want to power the probe, you can. As we're doing them ourselves, we are very flexible. Just tell us what you need and we will make an offer for it.
Yeah, two more questions, and then I think we should we have to end this here. We can always continue the private conversation. I think this is something worth to mention and important to say. 50 meter is not a limitation. We will talk about that also in the next webinar. This is a little bit of difference from our basic heated sample line to the plus heated sample lines. Plus heated sample lines can be longer lengths regarding the heating circuit, but let me tell you, we have so many ways of configuration. We've been producing lines 200 meter in one piece. Then we have to operate with different heating circuits, a little bit more complicated, but you shouldn't worry. We take good care of that. And last question is the percentage of moisture can be removed, PSG cooler. Jemsen, what would you say? What would we recommend there?
Yeah. So So let me explain. You know, in the cooler itself, there are a couple of things that we have to consider. Yeah. Firstly, the heated sample itself, before it enters into the cooler, it must above water and acid dew point. That is a critical number one. Yeah. So number two, that at the point of entry, the sample must again above water and acid dew point. This is so important so that you do not have a long unheated naked tubing goes into the gas cooler. Number three, you have to ensure that the sample pump is not higher than our specification. All right, It is not higher than. Number four, we have an option. The cooler is able to take the amount of water. It is the peristaltic pump that is not able to cope with the amount of water that's draining out. That means that in such a situation, let us know. We can increase the peristaltic, the flow rate, the pump out by double the speed. Yeah, does that answer your question?
Yeah, I think that is a good question. If it is possible to answer that question in quite general. So I said last questions, yeah? No. So we do have a full certification for the hazardous area, and allow me to invite you to our next webinar. Actually, the webinar regarding ATAX will be in 2 months. It's quite some time, but allow me to give you this overview here. And we are very happy about your questions. We are very happy about your comments. I can stop here. QR1 certified lines. You are right. There is an effect on the T90 time, and I think from region to region is more or less strict how this is handled. Sometimes when you go into a qualification, QRL1, by the way, is the European system for the quality insurance of the sample handling of the entire emission monitoring system. And this is something where all components are described. So we recommend the OEM, or we recommend the people who apply for the certificate to go into the measurement with a very long line, sometimes smaller inner tube diameter, so that the T90 time will not suffer from a longer line. Yeah, that makes you more flexible. Exactly. And guys, if you want to have the presentation, we are happy to share it with you. Just leave a message, a private message, PM to Jonas, to Jemsen, or even to me. And then we are happy to share this with you.
Right.
Thank you so much.
You're most welcome to send as many questions about the sample probe directly to me. I will give you all the answers. Yeah.
That is so true. Guys, thank you so
very much.
It was, again, so much content squeezed into such a short amount of time. The first webinar 2023, I really enjoyed it. Thank you, Jemson, from Singapore. Jonas, I think it makes the impression you always have been participating here. Thank you for being part of this, and I wish you all a good time, and and all the best. Okay,
thank you. Bye.